You are listening to a universe of possibilities. This is Astronomy FM.
Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy.
Hello and
AFM
welcome
Radio,
to
AFM
York
Radio,
Universe,
AFM
the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined here tonight by two intrepid explorers. We have with us tonight Satish. Can I say hello?
Hi everyone, good evening.
And of course, Professor Paul Delaney.
Greetings and salutations, everybody.
Yeah, we are indeed very happy to be here tonight because we have a clear night in Toronto and we are broadcasting live from the fabulous Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. This is Astronomy Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, and then on to Western World's Quirks and Quarks and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time, or ET. Tuesday morning at 2 a.m. UT if you're in a different time zone. And of course, this production works in concert with our online public viewing. So live at the telescope right now, we have our wonderful staff of Connor and Obata pointing the 1 meter telescope up at the sky and seeing what they can find for you. So if you'd like to go ahead and hop over to the observatory team and watch along, you go over to observatory.info.yorku.ca and follow links to OPV online public viewing and join in the chat. You can also, of course, just navigate over to our YouTube channel, York U Observatory on YouTube, and find it direct there. This broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments you have about our past shows, or if you have suggestions for future topics, please send us an email at observed@yorku.ca. As a little note, you can also connect with us on Twitter and Instagram with the handle at York Observatory and Facebook at Allan Carswell Obs. All of our programs are free, but if you'd like to make a donation, you can see our website at observatory.info.yorku.ca. So let's go ahead and dive in here tonight. We've got all kinds of great historical and current events. But before we start off, I'll just say, thanks again to Paul and Satish for joining me tonight. It's been we had to actually drag them inside away from the stars to get everyone here.
It's always worth the effort, though, that's for sure. But as you pointed out, it's a clear night. And, over the weekend, Satish, I hope you managed to poke your nose out and see the beautiful full moon and Jupiter really close together.
I have nothing to say to that.
Oh, Satish, what have we told
That's
you
fascinating.
about
Nope,
going
that was
out
the
after
second
sunset? I mean,
Well, as they say, if you have clear skies, do not forget to look uppity. It's not just a wonderful moon, but we have a very bright Jupiter, just got done with opposition, and the keen-eyed amongst you may also be able to spot the brilliant planet Saturn, which is somewhere around. So it's a wonderful, wonderful observing sort of evening.
and those two planets in particular, always wonderful sights. I know you are keen on Mars, Elena. That's your middle name, or it should be. But Jupiter and Saturn, the belts of Jupiter, the rings of Saturn, they are really spectacular in the 1 meter telescope.
Yeah.
Absolutely, absolutely. And I have to say, as much as I did enjoy Mars, I am very much looking forward to the wonderful images of Jupiter we're hoping to collect tonight. All right, so I suppose I should start us off here with a little bit of history. For speaking of space, well, if we could launch our telescope into space, we might consider it. Get rid of that pesky atmosphere. If we go all the way back to 1989, August 23rd, there was a really interesting space. Recall the Soviet Union's very famous launch site, a Soyuz U-2 launch vehicle launched up something called the Progress M1. And that sounds very technical, but it was actually part of a really large set of Progress spacecraft. So I believe there were 64 Progress spacecrafts in all that went up to visit the space station Muir when it was in orbit. And this particular launch in, let me say, 1989. So this was not terribly recent. This is a while ago. I might be dating myself, but I was fairly young. And this is a really interesting launch because it was all new vehicle design. So this was an unmanned supply vehicle, which could go up, and I believe this particular one was something like it would have about a 100-day mission or so. And this particular launch tested out their new vehicle design for that Progress M1, which, as I mentioned before, would go on for some very, very large numbers, 64 different missions or so, at least. And the spacecraft itself going up to Muir, docking with Muir on 2 days later, August 25th, and then it was actually destroyed in reentry. So it had a little bit of a dynamic, if you will, dynamic trajectory. It docked, I believe, for about 98 days up on the space station, and it had on board lots of different conditions and expendable materials that they could, take up to that Muir space station. And if you look up the Progress set of missions, it's interesting that this one was in particular unmanned because they actually did have them crewed quite a lot of the time. And I was looking up earlier trying to find out if it was an accident that it burned up. But it was in fact deorbited on purpose.
Correct.
And burned up in the atmosphere over the Pacific Ocean.
South Pacific, to be very specific. That's the graveyard. Pacific. Yep.
And so, yeah, it was a really interesting flight and a really interesting program as well. So there's actually a whole bunch of different variations on the Progress spacecraft. Just for everyone's knowledge, this is the first Progress M type spacecraft. So they have lots of different designs that they tried out, and they had different types of attitude control systems and all kinds of cool things. So very, very fun, little bit of history happening in 1989. And if you get a chance to look at the design of some of these old spacecraft, it really conjures up a lot of images of things that I would have, when I was younger, would have thought were very science fiction. So it's a lot of fun.
When all is said and done, the Progress series has been the mainstay of the Russian space program as far as resupply to their space stations is concerned. I mean, they still fly variants of the Progress up to the International Space Station. They, apart from bringing consumables, they also bring up fuel, and it's pretty standard for them to deorbit dynamically, as you said, into the South Pacific. Very, very successful program.
Indeed, and it is worth mentioning as well that for all that these were, deorbited, they were actually quite, massive devices back in the day. So it's compared to the small microsats, especially that we regularly launch up to the atmosphere now.
Oh, that's right. Full of garbage. There are several thousand kilograms. So, but fortunately, it is designed for this dynamic reentry. The vast majority of it breaks up and vaporizes in the atmosphere, and relatively little actually ends up at the bottom of the South Pacific, fortunately.
Exactly, and this is the exact same kind of theory or idea people have between trying to make space debris deorbit, because a lot of it will burn up in the atmosphere very easily. So if we could deorbit more things, it might actually be to our advantage long term.
Correct. And, just speaking about space junk, which I know we weren't with the Progress, but...
No. Progress is not, but...
No,
yes.
That's right. But there's certainly a lot of work being done on wooden spacecraft. I mean, the Japanese in particular are working very hard to fly some prototype vehicles, satellites, not nearly as big as Progress, but instead of the primary aluminum shell that contains the electronics, they're talking about a variant of balsa wood, actually. Obviously, it's protected on ascent inside the fairing of the ascent vehicle. But when they deorbit, obviously, wood doesn't contain a lot of rather obnoxious material. So when it vaporizes in the atmosphere, it's just wood particles and sawdust that rains down in the atmosphere. Really, really good for the environment. So it'll be interesting to watch over the next 10 years as we try to develop more, shall I say, environmentally friendly satellites that, upon disintegration in our atmosphere, don't cause so many problems for the atmosphere and thus you and me.
Absolutely. And as a little aside here, just taking a completely side turn, if you are still debating about going over and checking out the OPV, they have now a very lovely image of the planet Saturn coming in live right now on OPV. That's the YouTube channel, Allan I. Carswell OBS. So you can go ahead and navigate over York U Observatory YouTube, or you can go to observatory.info.yorku.ca. It looks really cool. You can see the rings, you can see the Cassini division, and you can even see the color. Those skies are very clear tonight. So
you're not allowed to go, Satish. You're up.
Yeah, and on that note, we're going to prevent Satish from observing this by asking him to tell us what happened in 1847.
I'll be happy to change centuries now, so thank you so much. Okay, so both the shout-outs, a couple of them, one from 1847 and the other one from way back in 1623. But what we can talk about more is the one from 1847. So August 23rd is a birthday shout-out for Sarah Frances Whiting. And far as I could understand, she's probably one of the first and the most prominent astronomers, women astronomers in our history, modern astronomy and all that. So she was, she was an American. She was a natural philosophy student, and I guess then, to begin with, a teacher of natural philosophy back in those days. And then astronomy and physics became part of her teaching curriculum. And this was in Wellesley College, Massachusetts. She also was the one who established the physics department over there. And then, excuse me, this was only second to MIT, like this was the second one after MIT to have an active physics department, plus an upcoming observatory, which is known as the Whiting Observatory. However, the Whiting is not the same as the Whiting in her last name. And she was also one of the people who instructed Annie Jim Cannon, another famous name, and she was also invited by Edward Pickering to observe his work on spectroscopic techniques. So that's how prominent she was. And then later on, she became the director of the Whiting Observatory and then remained a professor emeritus till the end. So without getting into the details of when or like where she was born exactly, just to put a shout out for her. And then the other one is for Stanislaw Lubienicki. That's the best I can pronounce. Excuse me. He was a Polish theologist, which I guess was the closest to science back in those days, in 1623. And then he was also an astronomer. He belonged to some kind of royalty, and we don't have much information on him otherwise, but the impact crater of the Mare Nubium on our dear moon has been named after him. So birthday shout out to him too.
He was certainly at the very beginning of, shall we say, modern astronomy. Galileo and company had really only just sort of, nailed down the heliocentric model of the solar system. The telescope, the refracting telescope, had only just been made, 15 years prior to his birth. And of course, Isaac Newton and the Newtonian telescope, reflecting telescopes later in that century. Yeah, yes. It really was, the beginning of an exciting era of scientific exploration all through the 17th century. So, yeah, he came along at just the right time.
Well, there's some sad stories related to his family, but we can't talk about it here. It was a time of change, I would say.
More exciting, I guess, was Sarah Whiting and her engagement with Pickering College, the Observatory, and so on. The turn of the 20th century, Amy Jane Buchanan, Henrietta Leavitt. Very, very exciting times for astronomy specifically, unlike the 17th century, which was exciting for science in general. The turn of the 20th century and all of the work that was being done by the women at Pickering College was just exceptional. We're talking about the beginnings of modern spectroscopy, the development of the Cepheid variable distance scale calculations, women being able to actually complete PhDs and be given the credit for it, and then be hired on as astronomers in their own right at universities. Really exciting stuff there at the turn of the 20th century.
What I also forgot to mention is that she was also one of the people who could replicate X-rays after Roentgen sort of invented them. So I'm not sure how big that a feat was back then, but I kind of think it was pretty eventful, or seems pretty eventful that she was riding two horses at the same time in those times. So
Well, if you're going to found a physics department, I guess you must be, quite up on physics research at that point in time. I hope she was careful. I mean, we know what happened to the Curies in that regard. That wasn't so cool, dying of cancer as a result of their research. So I'm hoping she was more careful. Looking at her birth and death, I suspect she was. She lived to be deep into her 70s, so that's a good sign.
It is, yes.
Yeah, and it is interesting as well when we look at the sort of the history of science and education going back. We of course we have more in relatively recent history the computers of Pickering, and that's in North America, and as you say, modern science. But we also have historical contributors, which was, I believe, Fatima Al-Furi, who has a much longer original name, back in, I think, 859 or so CE, founded the first university, first modern university, which I believe is still in some sort of existence. So you get this sort of interesting line back through history of women in universities and what kinds of roles they played throughout history.
You said 809 CE.
Yeah, I believe it's thought to be the first official university. Wow. Maybe in some competition with Timbuktu, if I'm getting my, if I'm getting my dates. So you start going back thousands of years, and I start to lose track.
Awesome.
But yeah, it is very, very interesting stuff. Now, I think we're going to do some more date skipping around here, because next up, we have something straight out of the 60s. Paul, this is you?
Yep, this sure is. Absolutely. So I'm going to drag us back to the beginnings, or near to the beginning, of the space era. Recall, of course, October 4th, 1957, that was the launch of Sputnik 1. And, both the Soviet Union and the United States began to pepper our night skies with satellites. And it wasn't too long before they started shooting these spacecraft out of the Earth's gravitational field, past the moon, and of course, after we had successfully done that, it took us a few attempts to do that successfully, the sights were set on the nearest planets in our solar system, namely Venus and Mars. We've spoken about Mars a lot over the years on this show, and of course, why not? Because we've got some fabulous missions that are engaged in Mars, the other planet in our solar system that is most likely of all of them to house the signals of life, the present life. But we shouldn't forget that Venus was also a target in those early days. And in fact, the Soviet space program and the Russian space program invested a significant amount of effort, energy, money, time, resources in trying to get to Venus, the surface, in orbit, to better understand that planet. And they were, in large measure, successful. But it took a lot of failures to get to those successes. And unfortunately, one of those failures was back in 1962, August 25. This was the launch of the Venera 2MV-1. Sounds really good, doesn't it? The Sputnik 19 vehicle. Now, remember, back in those early days, it was very, very common for us to try and launch to the planets double probes. And that was simply to try and increase the probability of getting at least one of them successfully to the target. Well, the Venera 2MV-1 was one of those unsuccessful vehicles. It was launched from Baikonur, as Elena mentioned earlier. It's one of the most famous launch sites in the Soviet Union, now in Russia. And this was a 4-stage rocket. The first 3 stages all performed beautifully, and the Venera spacecraft made it to Earth orbit, hung out in Earth orbit for about an hour, and then the plan was to fire the 4th stage engine to break it free of the Earth's gravitational field, put it on a heliocentric orbit in towards Venus, and obviously eventually pass by Venus and take some of the first images of, Earth's twin planet in our solar system. That was the plan. Unfortunately, when they were prepping to fire the main engine, it was meant to be a 240-second burn. Unfortunately, it only burned for 45 seconds, the main engine of the 4th stage. And the main reason that it was running into difficulty is that just prior to the ignition of the main burn, there was sort of like a preliminary burn from a couple of onboard engines that was sort of, to prep the spacecraft, get it in the right orientation, get it in the right direction. Only one of those 2 engines basically fired. And as a consequence, the spacecraft, instead of sort of pointing like a nice straight arrow off towards the sun, began to have a sort of sideways torque associated with it because only one of the 2 engines was working. And then when the main engine fired up, bad news. So the 4th stage basically malfunctioned and left the spacecraft in an unstable Earth-centric orbit. Never cleared, never exited the Earth's gravitational field, and a few days after this rather lackluster, poor-performing 4th stage burn, the vehicle re-entered into the Earth's atmosphere. So bottom line to it is this Venera 2M5-1, Sputnik 19, was a failure. However, always looking for the more positive lights in this, there was a group of distinguished cosmonauts at the launch watching this vehicle. And in fact, it contained within the group Valentina Tereshkova, the first woman in space. She didn't fly until 1963. Remember, this is 1962. But a group of the cosmonauts were actually in attendance at Baikonur watching the vehicle launch the Venera 2MV-1. It was basically the same launch vehicle. The first 3 stages were the same vehicle that was to launch the various Vostok and Voskhod missions. Remember, Yuri Gagarin had flown the previous year on April 12, 1961, and very soon the Soviet Union was about to launch its 3-person spacecraft, and one of those early missions was to carry Valentina Tereshkova. And she was actually watching this launch, and as I said, the first 3 stages worked flawlessly, and those were the 3 important stages as far as the cosmonauts were concerned. So they left the spaceport very happy. Unfortunately, Venera did not make it out of Earth's orbit, so not quite so good. Anyway, bottom line to it is the beginning of the era of Venus exploration had started unceremoniously with this failure back on August 25, 1962. But as I said, the Soviet Union went on to put many of the Venera spacecraft onto the surface of Venus successfully and sent back images from the surface, not to mention invaluable data that they acquired during descent through the thick atmosphere and actual landing. By comparison, for example, NASA has barely made it to the surface. Their Pioneer Venus 1978 mission did in fact get a probe to the surface, but by and large, NASA has been spectacularly unsuccessful in its attempts to put vehicles on the surface of Venus, by contrast with the Soviet space program.
Indeed, and it was an immensely successful program all in. It's sort of astonishing to look at what they were doing.
by and large, NASA has been spectacularly unsuccessful in its attempts to put vehicles on the surface of Venus, by contrast with the Soviet space program.
Indeed, and it was an immensely successful program all in. It's sort of astonishing to look at what they were doing in this period. And if you ever have a chance to just go back and read sort of the list of launches that were happening. There are so many things going on at the same time. This is as you say in 1962, all the way through the 80s. It was immensely successful. Lots of rockets launching, all kinds of various different things. Everything from weather satellites to probes for other planets.
That's right, exactly. I mean, there were a lot of early failures because we basically didn't know how to put rockets together. I mean, these are big bombs. There's that much energy that's involved in a rocket launch. And in those early days, unfortunately, we didn't lose anybody in those early mishaps, but we certainly did lose a lot of spacecraft.
Yes, well, and the better spacecraft than the people. But yes.
Absolutely. No question in the world about that. And you learn from every failure. I mean, in fact, arguably, you learn more from the failures than you do from the successes, as long as the failures are only pieces of metal and sort of rudimentary computers.
Exactly. All right. Well, and it's actually very handy that you mentioned sort of the first female Russian astronaut, because I'm going to go a little bit of a different direction, and I've actually got a connection through to the first U.S. Or first American, I should say, female astronaut, in by way of a happy birthday shout out to Arthur Bertram Cuthbert Walker II, who's got an awesome name. And I was looking at it earlier, realizing it's actually ABCW, would be the initials. So
Yeah.
It seems like a really good set of initials for writing papers, which he did a lot of. He was born in August 24th, 1936, and he was a Black American solar physicist and educator who was absolutely instrumental in developing X-ray and ultraviolet telescopes. And unfortunately, he did pass away in 2001, but he achieved an immense amount in his time here, including using the very first X-ray and ultraviolet telescopes to capture actually detailed photographs of the sun's outermost layer, the corona. And the corona was, and actually still is, quite mysterious, how it's heated, how it works. And in 1987, his telescopes were the first ones to actually show what that structure sort of looked like. It's still his techniques and telescopes and the technologies he developed are still widely used in cosmology and astrophysics today. So Arthur Bertram Cuthbert Walker II, absolutely key to astronomy as we know it. He developed the technologies that are in use now in NASA's solar telescopes, and actually the fabrication of microchips, which you might have seen in, I don't know, everything. Microchips in your phone, microchips in your refrigerator now. Microchips are everywhere, as well as, of course, microsatellites. And he was a professor at physics at Stanford from 1974 until he passed away in 2001. He was really instrumental in encouraging racial minorities and women to pursue careers in space science and exploration, including, and this is our tie-in here, Sally Ride, the first American woman astronaut to fly into space in 1983. And in 1986, Ronald Reagan appointed Walker to serve on the commission that investigated the causes of the Space Shuttle Challenger disaster. So he was a really quite an amazing person who did an immense amount for science, for astronomy, for life as we know it. You mean the microchips and solar technology alone would have been quite impressive, but that wasn't all he did. He was born in Cleveland, Ohio, as I say, on August 24th, 1936, and he earned his bachelor's degree in physics from Case Institute of Technology in Cleveland in 1957. Got his doctorate in 1958 and 62. He got his master's and doctorate's degrees from the University of Illinois. And he focused on radiation energy and the atomic bindings of protons and neutrons, which is a good, sort of basic physics education background to get into, technology with. So he was, of course, not just a physicist and educator. He was also a first lieutenant in the Air Force, 1962, and in the Air Force, he helped create satellites used to study the Earth's protective Van Allen radiation belts. After he worked at the Air Force, I think from 1965, he went to an aerospace corporation where he directed a space astronomy program in the 70s. And then, of course, on and around his very prestigious career at Stanford, all the way up till 2001 when he passed away. So, really amazing person, Arthur Bertram Cuthbert Walker II, born August 24th, 1936, and definitely worth a great shout out for astronomy, physics, and, well, as I said, everything.
Very distinguished career, to say the least. That's for sure. Hadn't actually remembered that he was a part of the Challenger Commission. I should have, because it was, not that big a panel. But he was in great company there with Feynman, Richard Feynman, on that panel, and of course, as you say, quite instrumental in getting Sally Ride motivated to be an astronaut in the late 70s. Yeah, a very distinguished career, and fundamental physics. We still are grappling with trying to understand all of the ins and outs of our nearest stellar neighbor, and he obviously laid that foundation.
And encourage other minorities and women to pursue careers in space science. So it's very, very inspirational fellow.
Absolutely. Yeah. Hats off to him. Challenging times there in the 60s and 70s to be a scientist of color. And obviously he was more than successful at it. And to be recognized by the President of the United States as one of the most outstanding individuals to be placed on the Challenger Commission. Yeah, that shows you that, he worked awfully hard and did very well.
Indeed. And, I think it's always really fun to dive into these history facts, because you find out so much about cool people. I had heard of him before, but I hadn't quite really looked into him. And I'm like, wait a minute, he was doing this and the Air Force and he was on the Challenger Commission. This is amazing.
Yeah, that's right.
So I suppose we'll move up and over and around. We'll go up to, I think, the 60s next, getting back into our space missions, maybe using a little bit of the technology, microchip technology invented by Arthur Bertram Cuthbert Walker. Satish, do you have a new encounter, shall I say, in 1962?
Well, yes, and both of you have already spoken a lot about these kind of encounters. So let me just say, this is one of the places where, the successful parts of the NASA's, pro-Venus missions, because I guess we've discussed this before in one of the shows that NASA hasn't always been very successful at Venus missions. So this one is all Venusian. This is for the 27th of August, 1962, and I guess I pronounced this as Mariner, and then the number is 2. So this was a space probe for an encounter with Venus, and this was, a simplified version of the Ranger program designed to get up-close photographs of the moon in the same decade, of course. We all know that. So this was launched on an Agena B second stage, which is a typical or the specific name for the upper stage and satellite bus that it was launched on. It's not known to be as gracious as the Russian Venera Pros, which we just spoke about or heard about, because it had like lesser lift capacity, for example. And then it reached close to around 34,773 kilometers. That's the closest to Venus it could get. And this was in December 14, so I guess around 5 months down the line from when it was launched, the same year in 1962. And it had, of course, all sorts of fancy equipment, as Professor Pai just said, including a particle sensor or a charged particle sensor. So I guess this is where we're talking about the microchip thing. And then it was also meant to test communications from that general area, basically. So anything close to the Venusian area, it was meant to test communications from that point to planet Earth. And then along with making radiometric temperature measurements and measuring interplanetary magnetic field and also charged particle environment. So those were the primary objectives. And that's all I have about it. I'm sure you can add a lot more to those missions.
The Mariner 2 mission certainly heralded the very, very successful Mariner series. Mariner sort of went off to Venus, it went off to Mars, and basically it was the Mariner bus that became the pioneer missions out to Jupiter and Saturn in the 70s. Mariner was a wonderfully successful series. It really was. As you say, it was a stripped down type of probe. In fact, coincidentally, the Ranger 1 mission was disastrously attempted to be launched literally just days before Mariner 2. The Ranger series certainly was not very successful there until it got to about Ranger 6 or thereabouts. Anyway, as we said, the early 1960s, it was tough. And this was only a few days after the launch of the Venera spacecraft that I had mentioned earlier. But yes, Mariner 2, the first flyby of Venus, and it was NASA. And, we think of 34,000 kilometers today going, God, couldn't they get closer? But, the fact that they got that close was pretty darn good back then.
Okay.
Well, and speaking of things that lead us to Jupiter, I'm just going to put a little segue up here and let everyone know who is listening in. Over on OPV, they do have live images of Jupiter right now airing live from the 1 meter telescope. And it's only been a few days since opposition. 3 days?
Yeah, Friday.
3 days? Three
Yep.
days since opposition. So that means Jupiter is still very bright, very big, really wonderful. There are cloud bands. So there are all kinds of reasons to go to Jupiter. And if you do hop over to OPV, they will be happy to show you. So that's just in case anyone was wondering about reasons to go over to Jupiter. And if you do head over, make sure to say hi to Shannon, Matt, Sergey, Nathan, and our observers at the 1 meter, Obata and Connor, who are busily, I believe, trying to zoom in on the bands at the moment. So just a little. Yes, exactly. So a little bit of a side. And there are all kinds of reasons to go to space and all kinds of good ways to get there. I think we can go ahead and round off. I believe there's one more birthday announcement.
There is one last birthday shout out. This one to Katherine Johnson, born August 26, 1918. And believe it or not, she hung in there until February 24th. 2020. So she was a centurion, not a bad effort. She was one of the NASA mathematicians whose calculations of orbital mechanics were essential to the success of America's first and subsequent crewed space flights. So we're talking right back in the early 1960s, suborbital flight of Allan Shepard, first orbital flight of John Glenn, so 61, 62, really exciting times. And back then, computers, like real computers, well, they really weren't terribly reliable. As one of the first black women to work as a NASA scientist, Johnson's mastery of complex calculations helped pioneer the use of computers with the space agency. In recognition of her contributions as one of NASA's unseen yet heroic hidden figures, cue music of the movie from a few years ago, Johnson was awarded both the Congressional Gold Medal and the Professional Presidential, not professional, Presidential Medal of Freedom, America's highest civilian honors. Great movie, by the way. If you haven't gone and seen Hidden Figures, stop what you're doing. Go find it on demand and have a look at it. Really good movie, not just from NASA's perspective and the early era of the space program, but it talks about the period, bit of a sad period as far as the racial history of the U.S. is concerned, but it really paints Katherine Johnson in a terrific light. She was born in White Sulphur Springs, West Virginia in 1918. Johnson's fascination with numbers enabled her to skip ahead several grades in elementary school. Yes, she was very sharp. By age 14, she had already graduated from high school, and in 1937, at the age of 18, she graduated summa cum laude from the West Virginia State University with a degree in mathematics and French. After teaching in black public schools for 14 years, she went to work for the computing section of the National Advisory Committee for Aeronautics. That's the predecessor to NASA. NASA formed on October 1st, 1958. We only know the U.S. space program is NASA, but believe it or not, at the beginning it wasn't NASA, and she went to work for them. In 1961, as one of NASA's human computers, sounds a little bit like those astronomers from Pickering College there, Harvard College, back in turn of the 20th century, the human computers, the women who were looking at spectroscopy. I digress. So in 1961, one of NASA's human computers, Johnson did the trajectory analysis calculations for Allan Shepard's Freedom 7 mission. That was the suborbital hop, 15 minutes of spaceflight, great history, back May 5, 1961, America's first human spaceflight. In 1962, NASA had used computers to calculate the equations that would control the trajectory of the capsule that was to fly John Glenn on February 20th and his Friendship 7 mission. That was the first U.S. or Earth orbiting spacecraft. On February 20th, as I said, 1962, Glenn was prepared for liftoff, but he demanded, so the story goes, that Johnson manually check the computer's calculation for the flight. He is reported to have said, if she says they're good, he told Mission Control, then I'm ready to go. I believe that's a true statement, but it's a wonderful story. And, of course, the rest is history. It was a successful 3-orbit mission. So, at any rate, bottom line to it is that one of those really great hidden figures was Katherine Johnson, born August 26, 1918. Tip of the hat to her.
Absolutely. When you talk about inspirational folks, it's I have to agree. If anyone here hasn't seen the movie yet, maybe go see the movie or read the book, or
sure, read the book.
have a read about some of the things that she has done, not just for history, but not to be overly dramatic, but for humanity. I mean, this is an amazing person. So I am very, very pleased that she has started to get some good recognition for this.
Agreed.
And I think this is probably a good time to remind everyone that you are listening to York Universe, broadcasting live from Allan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you would like to find out more about us, you feel free to hop on over to our website at observatory.info.yorku.ca for chat, questions, or extra content. You can see us on Twitter at York Universe, also on Facebook, and of course at Allan I. Carswell Obs. And our YouTube channel right now is showing live images of Jupiter and 4 moons of Jupiter. So if you are tempted by moons of Jupiter, hop over to York U Observatory on our YouTube channel, or get there from our website. The crew is right now fiddling with the sizes and the magnification to view those live moons of Jupiter, very close to the opposition. So tonight you are listening to Elena, Paul, and Satish, and we're currently discussing all kinds of fun history things. And of course, every once in a while getting a little bit distracted because we have the online public viewing window open with the lovely moons of Jupiter, which has, if you missed it, just passed by opposition to Earth. So very, very bright, good angular size on that. And just as our little update reminders this week, if you haven't gotten tired of hearing me talk today, well, come on back on Wednesday at 7:30 over on our YouTube channel again. I will actually be giving a guest talk for our crew on data science, galactic archaeology, and astronomy. In other updates, Paul, I believe you were looking a little bit at the blue sturgeon or corn full moon.
Absolutely. I mean, this past weekend was full moon. I think it was technically first thing Sunday morning. So Saturday night and Sunday night were essentially both full moons in my mind. Interestingly enough, it was classified as a blue moon. Okay, this is that one definition which has always got astronomers a little boondoggled. There are two definitions for the blue moon. It's the second full moon in a month. That's one definition. Or it's the third full moon in 4 in the night were essentially full moons in my mind. Interestingly enough, it was classified as a blue moon. Okay, this is that one definition which has always got astronomers a little boondoggled. There are two definitions for the blue moon. It's the second full moon in a month. That's one definition. Or it's the third full moon in 4 in a given season. And so at this point in time, it's summer, the summer season. There are going to be 4 full moons between the summer solstice, June 21st, and the autumnal equinox, September 21st. And the third full moon of that 4 sequence is sometimes referred to as a blue moon. Well, hey, that happened this past weekend. And of course, because it was August, depending on which indigenous culture you're particular with, it was classified as the corn moon or the sturgeon moon. The sturgeon moon, of course, good fishing if you're into fishing. And of course, I love corn on the cob. Lots of corn in this month. So anyway, this past weekend, wonderful full moon. If you're out tonight in about now actually, it'll be coming across the horizon. Put on your sunglasses because it's incredibly bright.
Yes, fabulous, fabulous views of the moon, fabulous views of Jupiter, and I have to say Saturn was not too shabby either. It is now that we've finally gotten a nice clear night for public viewing. It's really paid off at the 1 meter telescope, but you don't need a telescope to see any of those things. So.
No, but the view does improve with magnification. But
it does. You get a whole different experience, shall we say?
That's exactly right. But hey, anytime you're outside, look up. There's lots of wonderful things to see.
Absolutely. And, I think actually we'll stick on our moon topic here for a little bit because there's some actually really fun new science news about the moon, which is actually one of my favorite topics. So, Paul, why don't you take this away?
Yeah. Absolutely. I mean, you would think that the moon being our nearest neighbor, we know everything there is to know about the moon. Cue the buzzer that says, no, we don't know everything about the moon. Not at all. And despite the fact that we have hundreds of kilograms of moon rocks and we've got lots and lots of spacecraft, including a lovely little a lovely little Chinese rover running around the moon at the moment, there is still much to be learned about our nearest neighbor in space. The folks out of Northern Arizona University, in fact, are looking very carefully at the lunar soil, in particular what we refer to as iron nanoparticles. Now, okay, quick reminder, the moon, airless void of an object, okay, so there's no atmospheric protection, which means meteors come slamming into the surface anytime you like, and they make holes and they sort of break up the lunar surface. There's lots of radiation that is beaming down from the sun onto the surface without any atmosphere, without any magnetosphere. All that radiation, both electromagnetic as well as particulate, goes slamming into the lunar surface, and it sort of just generally bakes the surface. For the longest time, we thought none of that really mattered too much, or at least in particular the solar radiation. We thought that that played second fiddle to sort of the asteroids and the meteors that were slamming into the surface and, if you will, changing the various properties, creating the breccia, the broken particles on the moon, and so on. But lots and lots of evidence is now accumulating that the solar radiation is interacting with the surface material, which is by and large very similar to the Earth's surface material. If you dig up stuff in your backyard and lay it out and dry it out, get rid of a lot of the moisture, the composition that you would have from terrestrial soil is not that dissimilar to what you find on the moon. A bit of a variation in terms of the percentage of magnesium and aluminum and so on. So there's a little bit of variation, but by and large, the sort of stuff that you would dig up in your garden, minus the water and of course the worms, you are going to find on the lunar surface. It is appearing that the interaction of the radiation from the sun with the surface materials is creating a lot more interesting chemistry, and I guess physics as well, than we had first thought. And one of these things is these iron nanoparticles. So imagine all of this stuff on the moon's surface, okay, and you're absorbing radiation from the sun, and that is actually breaking down some of those compounds and creating these relatively small iron-rich particles. Okay, you're saying, what the heck? Okay, but when we're talking about going back to the moon, we need to better understand what is on the surface of the moon, how that surface might be changing in real time, aka 2 weeks of sunshine. And of course, if we've got lots and lots of this particulate material, often referred to as lunar dust, that can become very abrasive if it gets inside, say, the joints of your spacesuit or into your lunar habitat. So better understanding what is actually happening at the lunar surface level, courtesy of solar radiation, is becoming increasingly important. There is also evidence that suggests that that interaction is actually generating, during the diurnal cycle, the day-night cycle, increased components of water, H2O. Now, we're not talking ice, we're not talking lakes and so on. We're talking about sort of, hydrated materials on the lunar surface. That is to say, the interaction with the solar radiation and the surface composition is generating, during the day, underscore the importance of this, a lot of the very near rover exploration missions that are planned, including a lunar rover from Canada, are going to be investigating these iron nanoparticles and trying to get a better handle on the chemical interactions which are happening on the lunar surface, courtesy of the action from the sun.
Absolutely, and it really is a wonderful thing to realize that there's so much left still to discover, especially if a lot of folks like to compare how would it be like to live on the moon versus Mars. And for a long time, the discourse was that you would have to bring everything with you to the moon. But on Mars, we know how to create, fuel. We know how to create water. We know how to create all of these different things. If that is also possible on the moon, well, then, what are we waiting for?
I don't know whether we're going to end up with skating options for the Maple Leafs, but nonetheless, if there's enough that we can actually distill to help out the water situation for drinking and breaking that down for H2O, for hydrogen and oxygen, hey, that's really useful.
Indeed, and I think a lot of us are. I've always been quite enamored with the idea of how do you set up a station or a habitat on these non-Earth bodies, but it's very, very fun stuff. So this is really interesting, especially if you get into what these different compounds can be used for. If you're looking at, okay, well, water generation is one thing, and what does this mean for their calculations on helium-3 abundance? What are these iron nanoparticles going to be really useful? It's just totally fun.
And we should see a lot of that in the really near future. Despite Jeff Bezos' lawsuit of NASA, I do expect we're going to be on the moon again within a small number of years. And that really is exciting.
I very much hope so, but yes, I think we have time for probably one more quick thing, and I think I'll just go ahead and give a quick word about something that we weren't able to see that we thought we should be able to see, and it's a fun article that you might have seen floating around about supernova, and supernova are these, of course, massive explosions that happen when massive stars die. They're extremely energetic events, and because they are so bright, they emit enough light that they can be seen even in distant parts of the universe. So we thought that there ought to be more supernova in the early parts of the observable universe, but observing them was something of a problem. And so, the fact that we can't observe something that's very far away, well, it gets a little bit chicken and egg problem, because you'd say, well, we think it should be there, but we can't really see it, but it's far away, so would we be able to see it anyways? And there's a lot of interesting things out there in the universe where we have predictions that we'd like to make, but it's not something that we are currently able to see. So enter the Spitzer Space Telescope, which has been around doing wonderful things for a long time. And to help find these more distant supernova, they had to be able to find things that were, of course, fainter, dispersed at these very, very large distances, possibly blocked by dust. And so they went ahead and looked in 40 sort of dusty galaxies, if you will, and they found wonderful things for a long time. And to help find these more distant supernova, they had to be able to find things that were, of course, fainter, dispersed at these very, very large distances, possibly blocked by dust. And so they went ahead and looked in 40 sort of dusty galaxies, if you will, and they found that the number of supernova actually does match. And so what it means is that there are many more supernova happening in the early universe than we had ever seen before. They were there all the time. We just weren't able to see them. So it's one of those interesting hidden in plain sight problems, and it's the nearby supernova in galaxies always agreed with theoretical predictions. So whenever you find something that doesn't agree, is always a little bit of a puzzle. And you say, well, is it because something is different in the early universe? Are our models wrong? And so you always want to verify with real observations any prediction you make. At least I always want to verify with real observations any prediction that's made. It's not always possible, because these galaxies in the early universe, they're farther in distance, but also this means, of course, farther back in time, because the light takes a lot longer for it to reach us, and that means we have this thing called look back time. So there's a lot more dust, a lot more star formation happening in them. So finding a supernova in that condition at this large distance is a challenge. So they turned towards 40 relatively close galaxies and found 5 new supernova. And Spitzer is an infrared telescope, so it's actually quite good at dealing with dust and gas. And the underlying